Hi everyone, it's Paul from This Designer. Today I'm going to show you what kind of speeds you can expect from your stock Voron 0.1 printer. And be sure to check out the sponsor of today's video, PCBWay. They offer print-on-demand services for 3D printing in every imaginable material possible. They also offer PCB fabrication, assembly, CNC machining, injection molding, and more. You can have your parts made in as little as 1 week, and they accept low volume orders for all services, which is very handy when prototyping your new creations. Check out PCBWay today. So I've seen many speed tests online of the Voron series. I'm pretty sure you all know that they can print ridiculously fast. I think I've seen videos of it topping out at like 1000 millimeters per second print speed. But when I was researching the Voron series, and specifically the Voron 0 series, I was just interested in what kind of speeds I could expect from just a newly built stock Voron. Today I'm going to show you what speeds I'm able to achieve. I finished building my Voron 0.1 in January, and this is the LDO kit, so bear that in mind. It's got no mods, no tweaks to it. This is just a stock LDO kit that's been put together by myself. So since I've built it, all I've done is 3 basic tuning steps to this printer. And those steps were extruder calibration. So that is where you would measure 100 millimeters of filament, you would tell Clipper to extrude 100 millimeters, and then you would measure to see how much it does actually extrude. You put those numbers into a formula, and then you've got your extruder calibration sorted. The next was just a basic temperature tower for the filament that I'm going to be printing with. This is my first time printing with ABS, and this is the eSun ABS Plus filament. I did a temperature tower, which you can see here, and it ranges from 265 to 225. Honestly, I didn't really notice any difference in the quality of the prints. I did just snap off each one just to see if the layer adhesion was affected by the temperature. I would say that, yeah, I mean, 225 up to like 240, it was a little bit easier to snap off. I've been printing this at 240 to 250, and yeah, I think 250 is a good temperature to print this at. But whenever you are printing with a new filament that you've not used before, always do a temperature tower. And the last tuning that I did was just a pressure advanced cube, and this will just tidy up the corners. If you're getting over extrusion or under extrusion on the corners, the pressure advance will change how the filament is distributed as it's printing. It won't change the amount that is printed, it will just change the distribution. When it gets to a corner, it will, if it's over extruding, for instance, it will just slightly reduce the amount that it's going to be extruding, just to make sure you don't get any of those bulging corners. And that was pretty much one of the only issues that I had as soon as I printed this. I did notice that I had a little bit of bulging on the corners, and printing one of these pressure advanced cubes, entering in the information that you need into the formula, it's tidied it up quite well. There are many more steps you can take to tune this printer, or any printer that is. I'd highly recommend taking a look at Andrew Ellis' print tuning guide on GitHub. He's put together a complete guide from A to Z of what you need to do to get the most out of your printer. So since I've built this Voron, pretty much most of the things I've printed, I've been printing at about 120 millimeters per second print speed. That's pretty fast, especially considering I'm coming from an i3 Mega, which is just behind me, and that I was usually printing at about 50 to 60 millimeters per second. When I was trying to get a nice looking print, I would maybe bump it down to 40. This can do 120 millimeters per second very comfortably, and it can print really nicely at that speed. Over the last few weeks, I've been pushing the Voron to see how fast I can print it. And from my initial tests, I'm maxing out at about 160 millimeters per second for the walls and the infills at a 0.2 millimeter layer height. I've found that trying to print at 160 millimeters per second at a 0.3 millimeter layer height, you really start to hit the bottleneck of this printer. You start to see quite a lot of under extrusion. The bottleneck isn't really the printer, it's not the printer frame, it's not the mechanical parts of the printer, it's really the hot end. That is kind of the bottleneck that I see at the moment on this stock Voron that I've built. And we can dig a little bit deeper into this, and this is the Phaetus Dragonfly BMO hot end. And you can go onto the hot end manufacturer's site, and usually they would give you a specification sheet of what the hot end is able to achieve for a flow rate. If we look at the Fetus Dragonfly, we can see that it's got a flow rate of about 15 millimeters cubed per second. So this is how much melted plastic it can push through the nozzle every single second. Now, if you know this flow rate number, there is an equation that you can use to estimate the speeds that you can expect from the hot end. If we use the equation of speed equals volumetric flow divided by layer height divided by line width, then we can get an idea of the speeds that we can achieve. So we know that the flow rate for the hot end is 15, and we know that we're trying to print at 0.3 layer height, and we've got a line width of 0.4. If we divide those, we get a number of 125 millimeters per second at 0.3. So this confirms my experience of trying to print 0.3 layer height at 160. As I said, I've been printing mostly at 120 for 0.3 millimeter layer height, and I've not come across any issues. And I think that 120 to 130 is probably going to be the maximum you're going to be getting from the Voron stock 0.1. And that might sound disappointing, but that is still very, very fast. 0.3 millimeter layer height, 120 millimeters per second. Yeah, that's much quicker than what I was able to achieve with my i3 Mega. If we do those same volumetric flow calculations for 0.2 millimeter layer height, we get a speed of about 188 millimeters per second. So I did do some tests at 200 millimeters per second, and because this was a small part that I was printing, it was just this arm here for an upgrade actually for the Voron. On the longest parts, when it was printing the walls, the longest part of this model, I think we was topping out at around about 190 millimeters per second. And the walls, they look fine. There is no issue of under extrusion. So yeah, I think that, 190, 200 millimeters per second at 0.2 millimeter layer height, I think it's definitely comfortable to print at. Now, I could of course just print a big cylinder or a big rectangle and show you those kind of speeds. And as I said, there are many speed test videos printing those basic shapes on the Voron. And yes, you are able to achieve probably higher speed rates, but I really just wanted to show you real world examples of what you can print at with a newly built Voron 0.1. So hopefully this gives you an idea of what to expect when you buy this. I highly recommend the Voron. I absolutely love this printer. I've been printing with it for about 5 months now. It just handles everything that I've thrown at it. It prints fast, it prints quietly. Yes, the build size is a little bit of a limitation, but I mean, as I said, most of the parts that I'm printing, are just little small parts like this for larger projects. When you print at 160, you do start to see some like ringing artifacts in the walls, which I think can be reduced by using some shaping tools within Clipper. I've yet to do that because I don't really care about how it looks, to be honest with you. I mean, this was printed at 200 millimeters per second, and yeah, it looks fine. It's nice and sturdy. The layer adhesion is good. So that's pretty much all I need. Lastly, I just thought I'd show you some footage of the Voron printing in real time. This is just printing a 3D Benchy taken from Thingiverse. And this is printing at 160 millimeters per second on the walls and also the infill. And I'll just show you my Cura settings that I use. As you can see, I just pretty much put everything to 160. And I'll slow down the initial layers. I put it to 70, sometimes 80. Just to make sure that I've got a nice contact between the print bed and that first layer. I keep my accelerations between 3,500 and 4,500. I think I've got them at around about 4,000 at the moment. As you can see, it prints fast. This is in real time, and I'll just show you just some footage of the results of the 3D Benchy. You can see there's a little bit of over extrusion in some places. I think I still need to tweak my pressure advanced settings, maybe my retractions as well. I've not even dialed in my retractions at all, so it could perhaps be that. So anyway, I hope you found this useful and everyone is doing well out there. But that is it for now. I will catch you all later.